Unit 3, Section 4, using a two-column proof for triangle congruency. In the last section, we figured out how to tell if a triangle is congruent to another triangle. We had 6 different postulates, and 4 of them would help prove that two triangles were congruent. What we're going to talk about now is something called a proof. In geometry, these are very important. Basically, it's sort of like you are using the information that's given to you, but you are actually explaining why you know something instead of just saying it's true. So let's look at what that means. So some vocabulary. A geometric proof is a combination of given information and statements that will show that something is true. So you are given something, and then you have to state something to prove that an actual fact is true, okay? So given is the information that is already provided to you through symbols or words. So it's important to know the symbols, and that's why I said in the beginning that if you don't understand the language or the symbols, you're going to struggle in geometry. The statements are things that you write that you are proving are true based on the information you have. You have reasons that explain, it's the explanation you're providing to show that the statement is true. And this is only one of 3 different types of proofs that exist in geometry. The two-column proof is one of 3 different types. In geometry, it is important that you know how to prove something is true. You will have information given to you, and then you will need to make statements, and you will have reasons to show that you have the knowledge. So here's a visual of what a two-column proof looks like. There was also one on the front title page. You see that there's a column for statements, a column for reasons, and there's some given information, and then there's a task to prove something is true. Let's look at examples. First, we'll start with some steps. This gives you exact steps. Start step by step, part 1 and then a part 2. I recommend strongly that when it is time for you to write these, you would use this as your guide. So you're going to first draw a diagram if there isn't one. Most times you will get a diagram, but if you don't, you need to try to draw one as accurately as possible. Meaning if it tells you that things are equal, you need to make those tick marks to show that. Choose the correct theorem. So you've got SSS, SAS, ASA, AAS to prove that things are congruent. Part 2 is setting up the proof. You're using a T-chart. You've got the heading statements and reasons. You write down the givens because you've already been told those, so there's no reason to spend a lot of time thinking about that. Use the correct theorems, definitions, and postulates as reasons. So you have to look back sometimes and find those things because they aren't going to all stay in your head. Make sure your proof is in a logical order. The steps should make sense in the order that you wrote them. And here's a hint. Sometimes it works to start at the end and go backwards to make sure you have included all the necessary parts. Let's look at an example. All right, so in example 1, in the diagram given below, prove that triangle PQW is this triangle here. And I know that because here's the P, here's the Q, here's the W. Prove that it's congruent to triangle TSW, this triangle here. All right, so we've got our 2 triangles and we need to prove that they are congruent. So let's take a look. First of all, I can say that line segment PQ and line segments ST are congruent. And I say that it is given because I saw one tick mark. That tells me that those 2 are congruent. Do you see the symbols? The way that this was written was a line segment because that's what it is. And with the 2 letters that label it. Remember, that was our very early on, couple of units back. We learned how to use the symbols. All right, so then we also know that PW, which is this one here, is congruent to TW, which is this one here. QW is congruent to SW. And that means that since I've been given all the information, these 2 triangles are congruent. And I'm using the side, side, side postulate. This was an easy one because they gave you everything. They're not always going to give you everything, but they didn't tell you what kind of postulate to use. You did that because you knew from our previous unit what those postulates said. Let's look at A second example. In the diagram given below, prove that triangle ABD and EBC and use that they're congruent using a two-column proof. Sometimes it's helpful to just trace the triangle so you know exactly what they're saying. All right, so here we're given BD is congruent to BC. Once again, we're given that because I see tick marks, right? So the tick marks help us to know what information is already there. Then I see that AD and EC are going to be congruent, AD and EC. And that's also given. There should be tick marks there if we know that they're congruent. Angle D is congruent to angle C based on alternate interior angles. Alternate interior angles. Because these are two parallel lines and this is a transversal. So think about it. These are alternate interior angles. Let me show that a little more clearly without so much writing. So if this is the parallel lines, this is your transversal. This angle and this angle are alternate interior angles. So we're saying that they are equal. And then angle ABD, which is this angle, and EBC, which is this angle, we know that vertical angles are equal, so we know that those angles are equal. So we were able to prove that these two triangles are congruent by angle, side, angle postulate. We were able to find two angles based on other theorems that we knew, and that proved that these two triangles are equal. So that, we pray, gives you a better example of what a proof is, because you do have to have background knowledge in order to prove something. You can't just say it's true. You have to say why, and you have to use geometric theorems to prove it. So you're going to need to go back and gather your resources. I wouldn't try to do these problems without anything in front of you. I'd go back and find what can be helpful as a resource and then try to tackle your exit ticket. All right, best of luck to you.